So in the part 1 video, we have learned about the refractive index. Here is the formula for refractive index. So refractive index can be calculated for a transparent medium. So we are calculating the refractive index for two medium. Here we are calculating the refractive index of medium 2 with respect to medium 1, which will be equal to 2n1. The formula will be velocity of light in medium 1, which is v1, upon the velocity of light in medium 2, which is v2. You have to put in the values and find out the answer for the refractive index. Now, if you are calculating the refractive index with medium 1 with respect to medium 2, the numbers will change alternatively. 1 and 2 will be equal to v2 upon v1, that is velocity of light in medium 2 upon velocity of light in medium 1. Now here are the three different ways in which the light will refract. That is the refraction of light in different medium when it enters from rarer medium to denser or denser to rarer. So how it is going to travel. So first we can see that when a light ray passes from a rarer medium to a denser medium, as you can see in the figure, it bends towards the normal. In the next figure, we can see that the light ray is passing from a denser medium to a rarer medium. And here when it passes from denser to rarer, the light ray, it bends away from the normal. And first it was towards the normal, and here it is bending away from the normal. Next is when the light ray is incident normally at the boundary between the two mediums, then it does not change its direction, and hence you can see that it is not getting refracted. So these are the three things that you have to follow whenever you are drawing any type of ray diagram with refraction of light. Now let us learn few more terms with refraction of light. So have you ever seen a mirage, which is an illusion of the appearance of water on a hot road or in a desert? Usually in movies they show this type of things. So local atmospheric condition affects the refraction of light to some extent, and in here, as the air near the hot road or the desert surface is hot, and hence the it is rarer than the air above it. The refractive index of air here keeps increasing as we go towards the height, as we keep on increasing the height. So if the direction of light ray coming from a distance keeps changing according to the law of refraction, so the light coming from a distant object appear to be coming from the image of the object inside the ground, and this is called as a mirage which is formed. Another effects of refraction can be seen when the object, you must have observed this also, that the objects beyond and above a holy fire, they appears to be shaking. So this again happens because of the local atmospheric condition which affects the refraction of light, and the mediums, it keeps on changing. So the direction of light ray coming from the object beyond the holy fire changes due to the changing refractive index above the fire, and thus the objects which is nearby to the fire, it appears to be moving. Now the effects of atmospheric condition on the refraction of light can also be seen in the twinkling of the stars. Now we all know that stars are self-luminous, and it can be seen at night in the absence of sunlight. So they appear to be a point source because of their being at a very large distance from us. So as the density of the air increases with the lowering height above the surface of the earth, the refractive index also keeps on increasing. So starlight coming towards us, traveling from a rarer medium to a denser medium, it will constantly bend towards the normal. and this makes the stars appears to be higher in the sky. uh, Actual position is different, but we feel that it is much higher in the sky. You must have also observed that the position of the stars keeps on changing little bit in some time. So this is again because of the motion of atmospheric air and the changing air densities and temperatures continuously. And because of this, the refractive index of air keeps on changing continuously, and because of this change we can see that the positioning or the brightness of the stars, they keeps on changing and the stars appear to be twinkling. Now you all must have observed that the sun, even before it emerges above the horizon, we can see the rays, we can see the light, and same thing happens at the time of sunset also. For a short time we can see, even after it is below the horizon, we can see some lights which is visible. So by sunrise we means that the appearance of the sun above the horizon, but when the sun is somewhat below the horizon, the light ray are able to reach to us along a curved path due to their refraction through the Earth's atmosphere. Now we can see that the sun, uh, even before it emerges above the horizon, because of the same reason, and the same thing happens when the sun sets, we keep seeing the sun for a short while even after it goes below the horizon. So let us understand what is dispersion of light. Now, if you hold the plastic scale, which is there in your compass in front of your eyes, and you see through it while moving it slowly, you will see that light ray divided into different colors. And these colors appears to be in the Vibgyor pattern. Now you know that light is an electromagnetic radiation and wavelength is an important property of the radiation. The wavelength of the radiation to which our eyes are sensitive is between 400 to 700 nanometer. We can only see the light in this particular wavelength. So what is dispersion of light? The process of separation of light into its components, colors, while passing through a medium is called as the dispersion of light. So it can be through a glass medium, through a water droplet. So as it is dispersing, it gives different colors. And this is how a rainbow or a Vibgyor can be seen. Now, Sir Isaac Newton was the first person to use a glass prism to obtain the sun's spectrum. So when white light is incident on the prism, different colors bend towards different angle. And among all the seven color, red bends the least and violet, as you can see here, bends the most. So the seven color emerge, they all emerge in a different path and they all get separated and we get a spectrum of seven colors. There is also partial and total internal reflection which happens. So when light enters a rarer medium from a denser medium, it gets partially reflected. And you can say that the parts of the light, they get reflected and they come back into the denser medium. So as per the law of reflection, it is called as the partial reflection. Only some part gets reflected. The rest of the light gets refracted and goes into a rarer medium. So now as here in the picture you can see that as light is going from denser medium to a rarer medium, it bends away from the normal. So here you can see that the angle of incidence I is smaller than the angle of refraction R. Now in the figure it is shown on the left side. If we increase I, R will also increase. And we can say that the refractive index is constant here. So for a particular value of I, the value of R becomes 90 degree. So when R is equal to 90 degree, this value of I is called as the critical angle. So for angles of incidence which is larger than the critical angle, the angle of refraction is larger than 90 degrees. And such rays return to the denser medium as shown in the figure in the right side. You can see that. This all the light they get reflected back into the dense medium, and this is called as the total internal reflection. So from this you can determine the critical angle and the total internal reflection. You must have seen a rainbow during the rainy season, but how the rainbows are formed. So rainbow is a natural phenomena, and it is the combined effect of the number of natural processes. Here three things happen together, that is it is the effect of dispersion of the seven colors, the refraction and total internal reflection of light. So all the three things happen, and this can be seen only mainly in the rainy season, that is when the rainfall is happening. So when light rays from the sun enter into any droplet, it gets refracted and dispersed. So then inside there is internal refraction, as you can see in the figure. Internal reflection is happening, and after that once again the light gets refracted, and while coming out of the droplet, so all of these three processes occur, and then this produces a rainbow. So because of the refraction, total internal reflection and effect of dispersion, a rainbow production takes place.